As a starter, you were asked to have a go at this exercise, which is an introduction as to why equating coefficients works. It's a technique for actually manipulating equations and being able to find two expressions that are similar. We're going to use it to take an algebraic fraction and split it into simpler expressions and one fractional element at the end. It leads to a skill called partial fractions, and one of the benefits is to do with graphing. If you can break down an equation so that you can see, right, there's an x to the 4 element, there's an x to the 3 element, you can actually build up the shape that the graph forms. So you're asked to give yourself 5 minutes and try and work out what this is. And they all do have the right forms. They're general though. So you haven't got a standard quadratic equation. You've got an equation of a line, but it's got values in, and you could probably work those values out quite quickly. So let's batch them up for you. Because this one starts low, goes high. Where are we? There we go. Starts low, comes high, goes low, goes high again. That one seems to have two stationary points. Well, two stationary points is a cubic equation. This one's got 3, and it's probably going to be a quadratic. It's got a sort of starts high, goes low, goes high again, but it wiggles in between. Because it wiggles in between, I would probably be able to say this is something like a quartic, and it's going to have a cubic in there because the bits in between actually make a cubic type of shape. Top one we know is line, equation for a line, and the last two shouldn't make too much problem. We've got a quadratic and we have a reciprocal graph. It doesn't matter what the factors were, I've played with them, moved them around, but each of these graphs are fairly distinct and are quite clearly matchable. And that's an important point for the equating of coefficients. I've got here two graphs. One's a quartic, one's a quadratic, and I'm going to try and make, first of all, if I had a general quartic, so I'll put in a minus 2x. Is there any chance of B changing a quadratic into that quartic equation? And with a little bit of playing, you should be able to turn around and say, yeah, I can't even get really close to it. Even if I moved it up and down. If I tried moving the graph up and down, I've got to do it by adding a number, have I? So if I do D, yeah. So I can now, even if I move this down, I can start trying to get close to the quartic, but it's not going to be precisely there. And if I try doing the other way around and try and turn this quartic equation, can I play with a value of A so it starts looking very much like my quadratic? And I'm not allowed to use a quadratic term because of course I could make the quadratic term the same. But first of all, playing around with the right numbers, I can't manipulate the quartic. It goes up too quickly or too slowly in different areas. So when the values are small, it's considerably smaller than the quartic. When I go above a certain point, the values get too big. I can't get the quartic to create a quadratic. And it's that which is the conclusion for equating coefficients. The only way to get a curve that follows an x to the 4 part is there must be a term that is x to the 4 in the equation. And that is the key idea behind this, is if I know that this has 4, and you've seen it before in normal algebra, it doesn't matter what I've got on this side, even if we've got a minus 3x to the 3x to the 4. doesn't matter what I've got on that side of the equation, whatever is on the other side of the equation, for them to be the same, this x to the 4 term must match up. I can't do away with this x to the 4 term and replace it with anything else. Or I can't make it smaller and add other bits to it to make it exactly the same graph as this. So the principle of equating coefficients says the coefficient of every term is preserved. You can only make x to the 4 terms the same as x to the 4 terms. It's just like when you were doing units when you were younger and basic algebra. You can't add an AB term and a B term and turn it into a B term. They're not allowed to change. So you've used equating the coefficients for a lot of your algebra life. But as soon as you put an index on it, a lot of people get confused. But it's the only way to get to an x to the 4 term on two sides is you must have two x to the 4 terms that are equal in some way. And we play about with them to make them equal. That's the starter dealt with.